Hello guys, welcome back. This is again I'm with you to discuss about our basic program for giving you the details of the steps involved in the earthing systems or in the substation. So I was away from the videos due to some personal reasons. So I'm back. I will try to be regularly give you this information which may be beneficial for at least few people, not for all, but some of the people who are starting their careers and who have some interest in this field. I appreciate for your subscriptions. You have given a good response. So today's topic is earthing system and substations. Will give you a basic guide. It will not make you a designer. It will not make you expert installation team member, but surely it will give you the basic ground for choosing any field. So let us go to see the importance of the earthing system in the substation projects. Is this right side you can see there the mold, there is a joint, cross joint done by a technique called CAD weld, or this is done and shown in a video in the quickly in the last after 2-3 minutes. You will be able to see how to make this joint and what materials are being used. So here in this slide, in this lecture or in this video, we will be covering the soil resistivity test report. What is the soil resistivity test report? For a designer, it is an input to design the testing, to design the earthing system based on the soil resistivity report. Please make sure that you have a correct soil investigation report which is consisting the soil resistivity test report. This soil resistivity test report is actually very sensitive item. Many designers, many project managers, they ignore this one and they find it very unconvincing soil resistivity report and costing too much cost. So if the soil resistivity is high, it will make a more cost for your project than your available budget. But if it is a low, either it will give you saving or it will be on the budget. Actually, I will be discussing in detail that how soil resistivity test report will impact the cost of the earthing system. We will now go to the ideal condition that the soil resistivity test report is normal, and we are giving this report to the designer. Based on this, designer is a third party designer which will integrate, which will not tie the knots of your systems. So in Saudi Arabia, in any Gulf countries, the client has the approved designing firms, designing agencies. They will give you this service on a paid service, and you will be able to get the design approvals from the client. It is not like that any designer can come and submit his design to the client. So basically, this designer is your key member for the success of the project. Now let us move. This designer will give you a design, approved design, and he will give you a bill of quantity of earthing material so that you can execute at the site. In the last, we will show you the execution at the site from the real substation video where these steps are being carried out by actual system and actual people and actual tools. Let us move. Soil resistivity test, as I told you, it is done by the third party, client approved. They have many number of third parties, agencies who can take the samples from your substation and they will do the testing in their laboratory. The input to this testing agency is this borehole location plan. This borehole location plan is one of the initial drawings which we are giving after the site handover. This borehole location, if you want to see, you can search it or you can write me. I can share with you the borehole location drawings also to explain to you, just to give you an idea. This borehole location will have maybe 20 10 boreholes which will be used to dig by special equipment, rigs, and then they take the sample of the soil and then they do the soil investigation. And this soil investigation will include the soil resistivity which is of use at this point, at this time, for our earthing system. Soil resistivity report looks like this. You can see here in the left side you can see the electrode distance. Basically these are two electrodes, one is placed at one place and other at a distance of 1.5, 3.0, 4.0. Naturally you will go away, the resistivity will be increased. So there's a standard to accept this one. So in our case our soil resistivity report is good and we are using it as a input for the earthing calculation. The designer will take the inputs just shown in the left side, which is showing the conductor diameter, electrode diameter, thickness of asphalt. This is the asphalt when you will be finishing the project. This earthing system has to be designed for the fully developed substation, not during the natural soil or the open soil. So output, you will designer will give you the output that what is the tolerable step voltage, what is tolerable touch voltage. Step voltage and touch voltages are two different topics, very important, related to the human safety. So you must understand this one, but here I only tell you there is the tolerable limit and there is the actual limit. Actual limit should be less than the tolerable value. So here it is safe in our result. Overall grounding resistance is 0.0719. This is calculated through softwares and it is safe by using these conductors. Total ground rod lengths are shown. Total length of the grid conductor is shown. Total length of the conductor is shown. So this below table will summarize all these results. After that, the designer will give you the BOQ for earth mesh look like this. The PVC conductor, bare copper conductor, test pitch, earth rods, T joints. There are five types of joints which we are doing in earthing system. T joint, cross joint, straight joints. Like in any kind of plumbing works, you are doing the joints. Sometimes we make the joint from bare copper conductor to bare copper conductor. Sometimes we are doing the joint between the bare copper conductor and copper tape, or sometimes copper tape to copper tape. So when you will be doing this actual work, you will be more familiar with these kind of concepts. Now I am moving to the video to give you the actual pictures or actual feeling how the thing is being done. Thank you. In this video, you will see here the copper bar is laid in a substation area for giving you some brief introduction that how the earthing cable is done. This copper golden color copper bar is a 240 square mm conductor which is used for the earth mesh, the main earthing grid in the substation. So now here you will see both sides they have laid the copper bar. Okay, this is the mold and these three conductors are coming to this mold. Typically this is a cross joint and this is joint four conductors in from four directions and the size of this conductor is 240 square mm. Now this one of technician is inserting the third one and the fourth one. We have to insert them properly because the joint will be proper if these conductors are properly inserted. Then you will open the mold box, the cover of the mold. You will see a space inside which is used for filling it with the explosive material. This is a powder. It's named 250 depending on the joint which you are doing. So in this cross joint we are covering this cables to avoid the leakage, and this mold you can see it has a hole and this hole must to be covered so that this leakage of this powder should not go directly on the conductor. Only the heat should go there, or this material should go smoothly after becoming completely heat up. So this two packets of the explosive material 250 are being added in this cross joint, and after that we will add one other strong explosive to start the reaction. That is the white color. We will add it now. You will see it. We have added it. Now we will cover this with the all the leakages of the mold, so that the and this leakage should not happen from the melted copper or any other material. If this leakage will happen, the cross joint will be not suitable and it will be rejected. So this is just manual method, but there are some sophisticated ways to stop this leakage. But these are the thousands of the connections which were done in the substations. So mostly this is allowable, and this soil is used to cover this one. You can see one red color handle is there, and you can see the mold, and the people are wearing the PPEs. This is a dangerous activity. It has the risk associated with that. So a proper risk assessment should be done in case of fire. So you should be prepared some fire fighting equipment near this. And now we will start it with a flint gun or lighter to start the reaction. So this here we are trying, and one spark it is not working, so we will use another attempt to start this reaction of burning. We will use the lighter. Okay, now great, this is done. This is just 1 or 2 seconds operation, where this all the powder is melted and heat has been transferred, and the material has been transferred to the joint. Now you will see the joint. Carefully we have to remove this handle, and then see here it is a joint. So these type of hundreds and thousands of joints are made in a substation project, depending on the area size of the earthing system of the substation. Hope you enjoy this video in the theoretical background. Let us see you in the next video. Thank you.